Hi Sarah, thanks for your email. I've got a picture of the question that you sent. This is your assignment for Thursday, I think. And you were asking about getting started. So the way to get started on this is to go back to the three sort of conditions for a function to be continuous. So if f(a) exists and limit as x approaches a if f of x exists, and then f of a equals limit of x of approaches a of f of x. So all of that doesn't really make a lot of sense when you just look at it in terms of symbols and stuff like that. But if you break it down, then if f of a exists, then for this particular function, they're asking us in number 1 to show that it's continuous at x equals 0. So does it exist at x equals 0 is the question, and yes, it does. It's defined as y equals 0 when x equals 0. So that one is already sort of, you'll have to state it, but it's already sort of taken care of. In the second one, the limit as x approaches a exists. So in order for a limit to exist, it has to be equal on the right side and the negative left side. And so in other words, as limit of this function, as you approach a from the right and you approach a from the left, then both of those values have to be the same for you to state that the limit exists. And so that's what you need to do there, is try a small value close to 0 on the right, like maybe 0.5, and a small value close to 0 on the left, like maybe negative 0.5. And just show that you get a true value and that those values are equal as you're approaching. And then the third condition is that f of a, the function at that value, so the function at 0, is equal to the limiting value of x approaching 0 of the function. And so if you take the derivative of 0, you get 0, and so that is true also, and so you have to show that by taking the derivative. And so for number 1, that's what he's wanting you to use, is the definition. I apologize if I'm not making much sense. I'm kind of sick today. That's what he's looking for you to do for number 1. And then for number 2, he's actually asking you to take your first derivative and then go through sort of the same steps again, and probably with less explanation this time, because you can refer back to number 1 with the stuff you've already explained. So I hope that that helps you get started. If not, email me back, and I'm happy to answer more questions for you if you need it.